Hello everyone, welcome to this module on peering. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this module, we'll look into the two different kinds of peering supported by the OCI Virtual Cloud Network service. Let's start with local peering. As the name suggests there on the slide, local peering basically means you are connecting multiple VCNs within the same region. So the graphic shows here, you have a region, Oracle Cloud Data Center region, and we have a VCN1 with an address space of 10.0.0.0/16, and we have a VCN2 with an address space of 192.168.0.0/16, and we want to connect these two VCNs. That kind of peering connection is called local peering. Why do we do this? The reason we do this is the resources within these two VCNs, both in the same region, can communicate using private IP addresses, so they don't have to go through your public IP addresses. Now, there can be multiple scenarios for this, right? You can have a management VCN which talks to multiple VCNs within the company. You could have a bastion host talking with multiple VCNs. You could have a load balancer or a DMZ, which is in a public in a VCN, separate VCN, and then it could be talking to other VCNs which are not in the DMZ. So there are various scenarios why you would use local peering all within the same region. Now, how does this work? The first thing we do is we create this gateway, as we saw in the previous module, called a local peering gateway, which routes the traffic between these two VCNs. You can see here there's a local peering gateway which gets created on each of the individual VCNs. And as we have seen in the previous modules, once you create this local peering gateway, you have to specify the routes for the IP packets. Otherwise, they don't know where to go. So for this local peering gateway on this VCN, the target is 192.168/16, right? So all the packets should go there. And for the other VCN and the local peering gateway, the address is 10.0/16, so that traffic goes onto the other VCN, right? Pretty logical. And the other thing you would do here, which is not on the slide because we have not covered, is you also need to open the virtual firewalls so you can let the traffic into this VCN from this VCN and vice versa. There are a couple of things you need to understand. It comes up in the exams also. The first one is the two VCNs in the peering relationship cannot have overlapping CIDRs. So if you have an overlapping CIDR here, let's say 10/0/24 address space here, it would not work, right? Because /24 is a subset of /16 there. So the peering you will not be able to establish a peering connection, and so on and so forth. So that's number one. Number two is peering is not transitive. What that means is if you have this VCN paired with this particular VCN, and let's say there is a VCN3 which is paired with VCN2, it doesn't mean that VCN1 is paired with VCN3. It doesn't mean that VCN1 can be paired with VCN3 through transiting through VCN2. That's transitive routing. It's not supported. So if you have three VCNs, 1, 2, and 3, 1 and 2 are paired, 2 and 3 are paired. You want to pair 1 to 3, you have to create an explicit pairing connection between 1 and 3. Transitive is not supported. Now, what is remote peering? Same concept, but now you're connecting VCNs in different regions. Why would you do that? The most obvious use case is disaster recovery. You want to do some kind of DRs, you have your VCNs connected, and you could, take backups, you could do DR between regions, right? So same concept as before. Now you can see two different regions, Ashburn and Phoenix, let's say in US, in the US, and you have VCN1 here, same address space as before, VCN2, but now they are in different regions. Now to do this, it's a little bit more involved process, because remember, anytime your traffic goes out of the VCN, you have different kinds of gateways. This time the gateway we use is the DRG, which we saw earlier. And what we do in the dynamic routing gateway is we create this capability called remote peering connection. So we create this remote peering connection, and that acts as a connection point for a remotely paired VCN. And same as before, you need to provide the path for the IP packets in the route table. So for this DRG, the path is to go to this particular VCN and vice versa. Like local peering, the two VCNs in the peering relationship cannot have overlapping CIDRs, and again, transitive routing is not supported also with remote peering. Well, with that, we already looked at different gateways which OCI supports today. Internet gateway, bidirectional going to internet, NAT gateway, unidirectional going from private subnets, doing network address translation, going to the internet. Service gateway, OCI going from a private subnet to OCI public services like object storage. And then dynamic routing gateway, taking the private traffic to your on-prem environment. Now, the two more additional connectivity options we just saw in this module our local peering gateway, where you connect two VCNs in the same region, and remote peering connection, which is part of DRG, where we privately connect two VCNs in different regions. The idea here is you are connecting VCNs privately, so resources can communicate using private IP addresses. So let's quickly look into a demo of local peering gateway. This is the setup we had in the previous two demos, where we had a web server, where a Bastion server, both in public subnets, and a database in a private subnet. And we were using internet gateway to go out, and we were using a NAT gateway here to get some updates for this database running here, right? Anyway, we are not going to touch any of these um, subnets and the hosts running within those subnets. For this demo, what we are going to do is, in the same region, we are going to create another VCN and a private subnet, because I really don't need a public here. And we are going to create an instance within the private subnet, and then we are going to do a local peering gateway, so we can pair these two networks. Now, for illustration purposes and to save some time, I already have this instance running, and it's a private public subnet, so I can SSH into it. But this one is a private subnet, right? And my this VCN and this particular subnet I have already created, and I've already instantiated this particular instance, so we don't spend time doing these things, which seem pretty logical, the way the setup should be. All right, so let me jump to the console. And right here you can see demo VCN is the one we just talked about, right? So this is 10/16, and it has subnet A and subnet B, as we were discussing in the slides. So right, subnet A, this is the web server. I'm going to SSH into the web server, right? And then there is no local peering gateway connected here, so you can see that created here. So you can see there is nothing here. And if I go jump quickly to the other VCN I just created, demo VCN2, address space of 192.168.1.0/24. It has a private subnet here, but again, you see no local peering gateway, nothing created here, right? Now, if I quickly jump to my compute instances, you can see from the previous demo, we have a web server running here, right? So this is the web server we are going to use to SSH to test the private connectivity and ping the other instance, right? So let me just quickly SSH into this instance. And this is the web server we have been using for the other demos. Now I also have my 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 instance running in this private subnet here, right? So I already have it created. You can see that it runs in this private subnet, and this is part of the other VCN with this 192.168.1.0/24 address space. So I picked this private IP here. You can see it doesn't have a public IP. And if I try to ping um, this IP right now from this particular server, I get no response, right? Because it seems logical. I'm trying to go from here to here. There is no local peering connection here. There are no route tables, security list open. So of course this is not going to work, right? So if I see here, ping is just, black holing the packets, black holing. I'm not able to ping that particular server. So let's change that. So first things first, I'll go to my VCN, and for my demo VCN, I need to open my security list and create a local peering gateway, change my route table. So let's do all that. So this is the default security list I'm using. So let me add an ingress rule here, which says that all the traffic coming from 168 I'm going to allow. And right here, this is the address space for my second VCN, and I'll say all protocol because I'm going to do ping. So let me just open it here. Pretty straightforward. If I don't open the firewall rules, I'm not going to be able to ping the other VCN and the instance running in the subnet there. Now, next thing I'm going to do is I'm going to create a local peering gateway here, because this is both sides. You need a local peering gateway in order for the peering to work, right? So I said local peering gateway for demo VCN, pretty straightforward. And then last thing I need to do is I need to send the packets to that local peering gateway. So I already have a entry in my route table here for the internet gateway. And if you recall, this is basically taking the packets from here to the internet gateway. So let's quickly go ahead and add another rule for local peering gateway. So I say local peering gateway is my destination, and what is my destination CIDR block I want to reach? It's 192.168.1.0/24. So this is the path for packets destined for this IP. I want them to go through the local peering gateway, right? Pretty straightforward. So I click add route rules here, and then pretty much I am done with this particular VCN. So let me go to the other VCN and do the same kind of things. So first things first, I need to open the security list here. So for this one, I need to open the security list coming from the other VCN, right? So this is the other VCN address space. I could actually limit it just to the subnet. I could do that, but right now, just for illustration purposes, let me just open the whole VCN. So I add it here, and then I need to create a local peering gateway here. Create a local peering gateway. And then in my route table, you can see there is no route here. So I need to make this a destination for all the traffics destined for this particular VCN. So I would pick this. And now the couple of things remaining, I need to come to my local peering gateway and establish a peering connection. Because we created all these assets, we have not joined the local peering gateways themselves, right? So I pick demo VCN, and then I pick the demo VCN local peering gateway, right? And I say establish peering connection, and you would see it says pending, and within a few seconds this would change to peered. If I go back to my other demo VCN, you can see here that it says peered, connected to a peer. And now if I come here, bingo, I can see that I'm able to ping my instance using private IP address because my local peering gateway is connected here, right? So you can see now I'm pinging from web to this instance using this local peering gateway, and it's working here. If I go ahead and if I remove the peering connection, if let's say I terminate one of these, for terminating, I have to first remove the rules. So if I go here and if I let's say just remove this rule, right? I say I just stop the peering. You would see that my ping stopped right away. So I lost that connection and I'm not able to ping anymore. So thank you for watching this demo. Hopefully it gave you a good flavor of how remote local peering works. Remote peering works similarly, but it's a little bit more complex. You have to create DRGs, etc. on both sides. Thank you for watching this demo. If you have time, please join the next lecture where we talk about security list and network security groups. Thank you.